Hello people across the internet. Today I'm going to introduce something to you I think is very special, Watson. Watson is a webpage that I have designed that has one purpose and one purpose only. It can design CRISPR molecules. So today I'm going to show you essentially how Watson works, why he exists in the first place, and how he can be used. At its core, Watson can be used to do three things. One, he can design the two parts of the CRISPR system, the gRNA and the Cas enzyme. Two, it can analyze the efficiency and safety of the system it has created. And three, it can display the final product. Let's start with number one. First, the user inputs the gene name and what the CRISPR molecule needs to do. Insert, delete, activate, modify, or silence. We have to specify this because each one requires a slightly different version of the Cas molecule. Once the system has this info, it can send the gene name to an API that returns the nucleotide code of the gene, which is turned into the gRNA by this function. You may notice that this code calls for the PAM sequence, but what is this? The PAM, or protospacer adjacent motif, sequence is like a trigger for the Cas enzyme to get ready to start acting on the genetic code. So once the gRNA is made, the Cas protein is decided based on the function, and a few more supplementary details are decided. The output is sent to the front end of the webpage to be displayed for the user. After we get all this information in place, or in line, the code sends the genetic code that can turn into the desired CRISPR protein to the AlphaFold database API. If you don't know what AlphaFold is, it's basically a tool that can predict the 3D protein structure of a given amino acid sequence. Fun fact, it was such a big deal that it literally won the 2024 Nobel Prize in Chemistry. Anyways, the API returns the 3D structure to the code, which is then displayed by a molecular modeling JavaScript library. And that's it. The data is then organized and decorated, and the website's all complete. But why did any of this matter? To put it in one word, democracy. CRISPR is a growing field with potential across any industry touched by the life sciences. That's anything from textiles to medicine, to agriculture even. But for this field to grow, we need people to get excited about what all this field can do, which is what Watson is meant to do. It's my attempt to get people excited about CRISPR by showing them that it's not just for PhD level scientists, but also for the everyday person. After all, there's nobody better to determine something's future than those who are going to use it and feel its effects every day. I suppose I've done enough talking, so why don't I show you? Once I'm on the page, I'll type in the name of a gene and what I want the system to do. For this experiment, I will do the TERT gene on the activate setting, meaning the TERT gene is going to be expressed more, aka longer telomeres, aka potentially reduced aging, at least according to some studies. We'll give it some time to process, and boom, we have our results. This gives us the actual gRNA code, the right Cas enzyme version, some data on how safe it is. This one appears to be pretty good based on the standards. Some other useful data, and the predicted 3D protein shape. So far we covered the what's and why's, but what about what comes next? Well, I would like to eventually add a chatbot to the system that allows the user to create a CRISPR molecule given just a function. And the chatbot will figure out what genes need to be involved in what way. I would also like to add a section that gives a downloadable file that contains all the information needed to synthesize a molecule. All in all, the future of Watson is to further break down boundaries between the common person and the future of gene editing.